Hi, welcome back. Today we have a question. The question is, the wind turbine considered in the previous example operate in the wind that has the velocity pattern during a day that could be approximated by half a sine wave as V equal to Vm sine pi t over 24, where t is in time in hours and Vm, which is a velocity magnitude equal to 8.5 meter per second. The question asks, calculate the theoretical maximum wind turbine energy produced during a 24 hours period. Second question, the wind mean energy velocity. The third question, the electrical energy generated 24 hours with the efficiency of 0.3 coming from the generator turbine. And lastly, the theoretical maximum wind turbine energy produced 24 hours when the cut-in velocity 3.1 and cut-out velocity 8 meter per second. So first we highlight the question. The question asks theoretical maximum wind energy for 24 hours and the wind mean energy velocity, the electrical energy generated 24 hours with the efficiency of 0.3 and the wind turbine theoretical maximum wind turbine energy for 24 hours period when the cut-in velocity 3.1 and 8.8 meter per second for cut-out. So without further ado, let we start our solution. Step number 1 is maximum wind energy. We know that the energy from the wind turbine coming directly from the kinetic energy, which is E equal to half mv squared, and energy directly related to power times. In order to get power, energy must divide with time. So this term we divide with time will get work rate, which is power equal to 1 over 2 mass. The time we refer to the mass. Mass divided with time is mass flow rate m dot v squared. Alright. So since mass flow rate here, right? Since mass flow rate here is actually equal to rho AV. So we shall replace rho AV in this equation. So work rate is equal to 1 over 2 rho AV multiplied with V squared. Finally, we'll get 1 over 2 rho AV cubed. Alright. So, in order to find the maximum energy from the wind turbine 24 hours, so we relate back the energy equal to power multiplied with times. The power here we got is in terms of W dot, and times refer here is over the period of 24 hours. So period is dt. And then we replace here P with W dot, which is 1 over 2 rho A V cube, and time is dt. Definitely we have dt. Integration if you want to find the durations of energy over time. Right? This is 0 over 0 to time. So from here, we know that 1 over 2 rho A is constant. We can move out. And V cubic, we can actually replace with the given here. V equal to Vm sine pi t over 24. So just replace again 0 to time. 1 over 2 rho A. V here is V. Remember, V given equal to Vm sine pi t over 24. So just replace here Vm sine pi t over 24. And then this is dt. Alright, so next is, this is, make sure the power of 3, yeah, because we have the power of 3 here. So next we multiply inside with the power of 3. And then we will get here 1 over 2 rho A Vm cubic sine cubic pi t, alright, over 24 dt. This is integration, alright, 0 to 24 hours. So we notice that we already shifted the 1 over 2 is constant, rho is constant, area is constant, v cubic as well is constant, because given here v cubic Vm is equal to 8.5. It is constant already. So we can replace all these things. We move to the outside. That's why coming in this way. Only left sine cubic pi t over 24 dt. So next, we need to do the integration of sine the power of 3. So this requires special knowledge of trigonometry. Integration of trigonometry. Here we write it again. 1 over 2 rho A Vm cubic. Alright, this integration 0 to 24. Sine cubic we expand into sine squared pi t over 24. And this is sine pi t over 24 dt. And we know that from the trigo function, trigo identity, sine squared theta plus cos squared theta equal to 1. Thus, we can replace this one, sine squared theta equal to 1 minus cos squared theta. So, replace this term in this term. Okay, so we will get 1 over 2 rho A Vm cubic, integration of 0 to 24, sine, we got 1 minus cos squared theta, which is, theta is pi t over 24. And again, sine pi t over 24 dt. Alright, in this part, we need to let u, our u here is cos pi t over 24. Because we need to do the integration, we use the substitution method. Let u equal to cos pi t over 24. So differentiate this one in terms of, this is du equal to, differentiate cos will get negative, sine pi t over 24. Inside here, we need to differentiate as well. So we will get pi over 24 dt. Alright, next we make the dt become the subject. We shift all this to the other side. Become du over negative sine pi t over 24 multiply with pi over 24. Alright, this term we're gonna replace dt here with this part. You can see here. Okay, we're gonna replace dt here with whole this thing. Alright, so let's replace this to ease our calculation. So energy here again 1. Okay, again Okay. Alright, our energy here is equal to 1 over 2 rho AVM cubic. Okay, integration 0 to 24 hours. And then cos we can replace with u because we let previously u equal to cos. Thus 1 minus u squared. And then sine pi t over 24. And dt we replace with all these things. U over negative sine pi t over 24 multiply with pi over 24. So we notice that we have sine, we cancel out. We have negative, we move to the other side. Okay, multiply. And this one as well, pi over 24, we move to other side. So we leave only 1 over 2 rho A V M cubic integration 0 to 24. Alright, this negative multiply with 1, negative 1. Negative multiply with negative, positive. So let make u become the first term because it is positive. U squared and minus 1 become the second term. We shift because we already multiply with minus. And then here pi over 24. This is over, right, pi over 24. This is du. Alright, this is where we simplify. Alright, now we can directly integrate in terms of du. So let's integrate 1 over 2 rho A Vm cubic. Integrate this. Okay, u cube. Okay, this is u. Better this one, we try to separate. U squared over pi 24 minus 1 over pi 24. Alright, it is easy for you to do the integration. Alright, this one I try to integrate. So 2 plus 1, 3 over 3 multiply with pi over 24 minus 1. Integration of 1 is equal to u. Okay, over pi over 24. This is as well 0 to 24. So we notice that previously we let u equal to cos pi t over 24. Now we shall substitute back. And 3 with 24 we simplify, we'll get 8. So 1 over 2 rho A Vm cubic. Integration of u cubic is cos cubic pi t over 24 over pi over 8 minus cos, this is u, replace with this one, pi t over 24 over again with pi over 24. Just replace this one with 0 and 24. That means 24 minus 0. Then you will get the answer. Okay, you try to substitute. The area here, previously we discovered that the area here is a turbine. So the cross-sectional area is circular. So pi r squared. So pi, remember that previously diameter is 50. Now the radius is 25. So multiply with 25 squared. So you will get the area to be 25 squared multiply with pi. we'll get the area to be 1963.5 meters squared. And then the density, previously we discovered using the ideal gas equation, 1.17 kilogram per meter cubic. And then we know that given the Vm here is 8.5 meter per second. Just substitute all these values, A, rho, and Vm into this equation. And we solve this one, 24, we substitute into this and this as well. Alright? So we try to solve this. 1/2, rho is 1.17, area is 1963.5, and the velocity cubic is 8.5 cubic. And then we try to solve this cos, okay, and then we try to substitute time with 24. 24 divided with 24 is 1. So cos pi is actually equal to -1. Alright, cos pi, which is pi in radian, we try to change into the degree. Radian of pi equal to 180. So cos 180 is -1. So -1, the power of -1, the power of 3 will get -1 as well. So because this one, we try to solve. Okay, we'll get -1, the power of 3 over pi over 8. Okay. And then minus 24 over 24 is 1. Cos pi is -1 over pi over 24. Okay. This is for 24 hours minus this term 0. Alright, so cos, okay, this is a 0, cos 0. Try cos 0 is 1, positive 1. So 1 cubic over pi over 8 minus cos 0 is 1 minus pi over 24. Okay, this one here. So try to solve this on your own, alright? And then you will get this one to be 16 over pi. This one to be 16 over pi. And okay, this one you will get negative. So you try to solve this, you will get 1/2, 1.17, 1963.5, 8.5 cubic. And then this one, 16 pi. This one minus 16 pi. This is minus positive. So you will get, here is 32 pi. So 1/2, 1.17, 1963.5, 8.5 cubic, 32 over pi. Okay. Thus, the final answer here, you solve, you will get 7,185.3 kilowatt hour. Okay, because this is in terms of duration of hour. Okay, this is the maximum. So this is the, we call as the available wind turbine energy. In order to get the theoretical, we have to multiply with the maximum efficiency. So the energy max equal to efficiency max multiply with the energy available from the wind. So here again 0.593, this is fixed 0.593 multiply with the available energy is 7185.3 kilowatt hour. Thus you will get here to be 4260.9 kilowatt hour. Alright, the next question asks, calculate the wind mean energy velocity. So based on our energy extracted to get it maximum, we can relate this to be the with the velocity. Okay, so by using this is question B. By using the formula E max, alright, equal to, remember we have 1 over 2 rho A V cube multiply with time, because previously we know that E equal to P times T. Power is equal to work rate, which is we discovered previously 1 over 2 rho A V cubic. You try to substitute here, finally you will come to this part. Okay, this is actually V means. So in order to get V mean is equal to energy max divide all this with 1 over 2 rho A with time, and then we do the square root of 3 because this is the power of 3. So E max previously we discovered 4260.9 kilowatt hour multiply with 10 the power of 3 over 1 over 2. Rho is 1.17. Area previously is 1963.5 and time here is 24 hours because we need to find the mean, alright, the average. The average from 0 to 24 hours. So we do over 24. And then don't forget to do the square root of 3. So finally you will get, okay, 5.37 meter per second. That is the V means. Okay. As the question C, electrical energy generated during 24 hours. So C, the electrical energy generated during 24 hours, we need to use the formula E. Okay, given that electrical energy, this is subscript E, is electrical energy equal to efficiency of electrical multiply with E max. Alright, it is given that the efficiency of electrical to be 0.3. Just substitute here 0.3 multiply with E max is 4260.9 kilowatt hour. Then the final answer is 1278.3 kilowatt hour. That is the electrical energy generated by considering the efficiency here. Alright, the next question is we need to find if the wind turbine has cut in velocity of 3 meter per second and cut out velocity of 8 meter per second. Calculate the theoretical maximum wind turbine energy during 24 hours. Alright. So for this part, we need to find the time when the cut in velocity, and given there is 3.1 meter per second, and the time when the cut out velocity is 8 meter per second. So this is the last question, D. Given here, we need to find Okay, the time, the specific time for cut in and cut out velocity by referring to the velocity profile, the velocity pattern profile. Alright, this is step 1. Referring to the velocity profile, V equal to Vm sine pi t over 24. So this we have the velocity is given, velocity in and velocity out for the cut in and cut out. So we need to find this time. So rearrange this one. Let's start with velocity cut in. Alright. Let's start with V cut in, which is 3.1 meter per second. And here Vm is always constant, 8.5. So in order to get the T, sine pi t over 24 equal to V over Vm. And then we move sine to the other side. We will get pi t over 24 equal to inverse of sine V over Vm. And then in order to get time, we move pi and 24 to the other side. Will become 24 over pi sine -1 inverse V over Vm. So of course we need to solve this first inside. So V here refer to 3.1 meter per second. Substitute in this part. T, let's say this is TA. T cut in equal to 24 over pi sine -1. V is 3.1 over Vm is 8.5. You will get T cut in to be 2.85 hour at this hour, right? How about the V cut out, which is 8 meter per second? Let's say this is TB. 24, just use this equation. Okay. 24 over pi sine inverse sine. This velocity replaced with 8 over 8.5. You will get 9.5 hour. Okay. For this part, and then second step. Alright. To determine the total energy during the day between T1 and T2 during the day, for example, afternoon, from T1 to T2, sorry, from TA to TB that we discover for 24 hours, since the velocity pattern is symmetrical with respect to 12 hours. Alright, so that means this velocity, the first 12 hour is symmetrical with another hour. So we know that this is V equal to Vm sine pi t over 24. Alright, this is velocity. So this is symmetrical. And for example, this is at time t. Okay, this is over period of time. Okay, for example, this is at time t, TA, and this is at time tb. And then it repeat again, TA and tb. Okay, 2 times repeating. Alright, because of repeating this one, we can simply say that energy here is equal to, okay, 1 over 2, this is coming from the kinetic energy, 1 over 2, alright, rho A V cubic, multiply with 2 times. Alright, this duration, because why 2 times? Because 12 hours, 1 time, and 12 hours, another second time. Okay, so that's why multiply with 2. So this one cancel out. We will get rho A V cubic. We do the integrations of time from TA previously we discovered and TB over dt. Here we need to replace integration of TA to TB with rho A. Velocity is given. We shall replace with velocity of the pattern. V equal to Vm sine pi t over 24. This is the power of 3 dt. And then we shall expand further. This we expand time A to time B, rho A. This is multiplied with this one. We got Vm cubic sine cubic pi t over 24 dt. Alright, so remember that previously we do the integrations of this part. Alright, so we don't have to do the reintegration back because it is the same. Just look at back our previous equation, integration of sine cubic. We got here is here. This is the final form. The integration of sine cubic will got cos cubic pi t over 24 over again pi over 8 minus cos pi t over 24 over again pi over 24 time A to time B, let's say. So just write it down here. We don't have to waste much of our time. Okay. So the time, remember TA is that we found earlier to be 2.85 and TB to be 9.4 hours. Alright, so we do the integration. Okay, rho A Vm cubic integration all these finally will lead to cos cubic pi t over 24 over again pi over 8 minus cos pi t over 24 over again with pi over 24. This is from 2.85 time in until 9.5 hours. Okay, just substitute the value. Try to solve this. Rho, right? Rho A Vm cubic. This is try to solve this one. You try to substitute time into this. Time into this. Okay. You will get finally 0.0947. Okay. You will get 0.0947 in this term minus this term 2.55 minus this term. You will get 2.06 minus 7.11. Okay. And lastly, to solve this, you will get rho A Vm cubic multiplied with 2.6. So just substitute rho is 1.17. Area is 7185.3. And then the velocity of M, magnitude 8.5, cubic and 2.6. The final answer is 3702 kilowatt hour. This is available energy, yeah. Again, in order to get the maximum energy extracted from the wind turbine, this is step number 3. Energy max must equal to efficiency max multiply with E available, which is this one. So 0.593 multiply with available energy from the wind, 3702 kilowatt hour. And finally, we'll get 2190 kilowatt hour. Thus, in order to get the electrical energy generated, okay, the question asks here, in order to get the electrical energy, calculate the theoretical maximum wind turbine energy, right? So, theoretical maximum energy, again, step number 4 is electrical energy. Efficiency given here is 0.3. Alright, to get the energy generated from that duration of time, E subscript E, efficiency of electrical multiply with E max. So 0.3 multiply with 2190 kilowatt hour. And finally, you will get 685 kilowatt hour. That is the final answer to get the E generated, the electrical energy generated. That's all.